Just starting up the recording. All right, if y'all ain't got no questions about the homework or nothing, let's look at what we're getting into now. Do. I have the Jeopardy music playing in my head right now. All right, so this is our new topic, right? We're going to be talking about graphs of normal probability distributions. All right, it's going to be real good.
Professor, I have a question.
Go ahead.
Considering I failed this test, right? Are is
Mhm.
the next test gonna be similar? Like, do I need to know things from the last test in order?
Nah, nah, it's always new material each test.
Okay, all right.
Yeah,
Thank
yeah.
you.
You're welcome. The next test is not going to have many topics on it though. Maybe like four, I think, topics, and that's it. Something like that.
I'm not 100% sure if you're like joking or if you're being serious.
Not for real. Only like four topics. It's gonna be a quick
Okay.
test. The next test. The test after it
Yeah.
though, that's gonna have mad topics.
Okay.
So,
Yeah.
Professor,
Mm-hmm.
I just wanted to tell you that I went and I took a practice test for an agricultural technician. And tell
Nice.
me why it was a bunch of standard deviation on this test. I was so
Wow.
livid. It was like 8 questions.
Dang. Wait, what is that test for though? I never heard of that test
It's
before.
it's like for agricultural inspectors.
Oh, cool. Okay, okay.
Yes, and I took the practice test to see where I'm at. And
Got
I'm good
you.
on everything else but the math part. But the math part is specifically like statistics, standard deviation, graphing. I was so upset
Mm.
because I did good in everything else but that part.
Because I
So
mean, you
now
you didn't
I
finish
gotta
learning
wait.
everything, so that's why.
Yeah, but I didn't
Mhm.
even finish learning the beginning. We passed standard deviation
We passed it, but there's more to talk about
and
with it,
stuff,
you know?
all this stuff. So now I have to wait to
Hmm.
be placed on the list to take the actual exam because I have to pass the practice exam first.
Got you,
Go figure, right?
got you. I mean, to tell you a little bit about how it ties in with this class, right? When we first started off and we were doing like, if you remember, like a mean, median mode, standard deviation, and all that, right?
Yeah.
So that's what's called descriptive statistics, right? So like that's like the beginning of the class. Then we transition into probability, right? So now we're about to like finish up our last talk about probability. And then after you finish probability, we get back into statistics, and then we start learning about something called inferential statistics, right? So it's like you learned some of the class, but you didn't learn all of the class yet. And then you took a test on it. So that was kind of hard. I'm not gonna lie.
Yes,
Yeah.
it was really, really hard, and I was so shocked because I didn't
Mhm.
think that, I would see this kind of work ever again. But in the field that I'm going in, yes,
Yeah.
I need to know how to do this stuff.
I got you. You gonna learn, don't worry. And over time, when you keep doing it again and again and again, like in your majors, it becomes a lot easier. Like you start knowing what to expect, what to look for, and stuff like that. That's another reason why I make these videos, because right now I might say something really quick and it might be over your head, but then when you're in the field and then you're like, wait, I heard that before, and then you go back and watch a video, then that's when you get the aha moment, and it all makes sense.
Yeah, I agree. I definitely agree with that.
Yeah,
But me, that practice test, it really made me like realize I gotta take this seriously.
I
Because I
got you.
really want that license really, really bad. And this is gonna be on the licensing exam.
Got you. Yeah, I mean, like, don't pay for the test until you feel confident that you could pass it, you know?
Yeah, but it's like if I don't, pass it, it's like half off the next go round. So
Well, that's not
just
bad.
to
That's not bad.
yeah, and I do I want to see exactly what's on it so I know what to expect, so I know what to study.
Yeah, that's fair. That's fair. Most definitely. All right. So let's jump into this. So graphs of normal probability distributions. So you guys probably heard about something called a bell curve, right? So that's kind of
Mm,
like what we're getting into
yes.
right now. So I'm gonna start off with this. Here we go. Make that a little bit bigger so everybody can see. All right. So one of the most important examples of a continuous probability distribution is the normal distribution. This distribution was studied by French mathematician Abraham de Moivre and later by German mathematician Carl Friedrich Gauss, right? Whose work, hold on a second, is so important, right? That the normal distribution is sometimes called Gaussian, right? The work of these mathematicians provided a foundation on which much of the theory of statistics inferences is based, right? So we're kind of making that transition now, right? This is a normal distribution curve, right? Also referred to as a bell curve, right? So let's talk about it a little bit, right? I want you to notice that your mean, more specific, your population mean, right? Mu is in the middle, right? And then if you go one standard deviation over to the left, right? So this would be like one standard deviation, you'd be here. If you go two standard deviations over, you'd be here. So on and so forth, right? That's going to the right. If you go to the left, though, you're actually minus one standard deviation, so negative one standard deviation. And if you go to the left again, you'll be minus two standard deviations. All right. So that's how the x-axis is written out in a normal distribution curve, right? Another thing to talk about is this thing called inflection points, right? So what an inflection point literally is think of it as a change point, right? I'm not gonna test you guys on this, but just for conversation reasons, just to tell you what it is, right? We have a thing in calculus called concavity, right? So we have two types of concavity. We have concavity up and concavity down, right? Think of this as like a palabra. You remember the palabras from way back when, right? So when the concavity is positive, you have a negative palabra, and when the concavity is negative, you have a what you call it, a positive palabra, so to speak, right? So what the inflection point is, right, is imagine that it's like a say I put two of these together, right? The inflection point is the point where it changes from going up to going down, right? It's like a change point, right? And that's what this is, right? It's a change point on the graph, right? So it goes from concave down to concave up. Go ahead. I thought somebody was going to ask a question. Okay. That's all I'm really going to say about this. I'm not testing you guys on this or anything like that. But just to show you what it is to tell you about the inflection point.
That was a lot. I got scared and I you just eased my pain when you say you're not going to test us.
Oh, nah, nah. You know what? I would love to test you guys on it, but there's more for me to talk about with it, you know? Because like it involves calculus a little bit, right?
Oh, so why are you teaching us this?
Because this is all tied in. Statistics
Okay,
is actually built off of calculus, right?
got it.
Yeah.
So let me show you guys something before I even
So that's a
jump
normal
back into
distribution.
this.
Bell curve.
Yeah.
Right?
Yeah.
Okay.
But let me show you something real quick. All right. So formula sheet, right? Everybody remembers this,
Mm-hmm.
right? So,
Yes.
excuse me one second. Sorry about that. So we spoke about this, the binomial distribution, but let me keep going down now. When I get to tables like this, like we're gonna talk about this. This is the normal distribution table. We didn't get there yet, but we're gonna get to it. But you see how there's like all these numbers, right? And this is the student t distribution. There's all of these numbers here, right? But where do they come from, right? That's what we're not going to talk about in this class, right?
We're not
But
gonna do that.
where it's coming from is actually a calculus formula, you know. So the graph ties into calculus, which is used to make those tables, right?
It's basically like the points, right?
Mm-hmm.
And it's telling you if it's on 3.4, then it's 0.0003, right?
Exactly. But that number that you just said, the point like 003 or whatever, right?
That's
Where does that number
3.3,
come
right?
from? Huh?
I'm looking at the table on the paper
Yeah. Like not the binomial in the normal distribution like that, like this one,
right there.
point
That's where I
zero
see
zero eighteen, right?
that'll be
Where does that number come from? What formula gives us that number? It's a calculus formula, you know?
mm,
So that's how it ties into the graph. So that's why like I'm mentioning it to you, but I'm not gonna go into details with it with you, you know? But but I do still invite any of you that want to switch your major to math, after you take calculus, we could talk about it. You know,
yeah.
that's still an option on the table, just letting y'all know. All right. All right. So applications of a normal probability distribution are so numerous that some mathematicians refer to it as a veritable Boy Scout knife of statistics. However, before we can apply it, we must examine some of the properties of a normal distribution. A rather complicated formula presented later in this section defines a normal distribution in terms of mu and sigma, the mean and standard deviation of the population distribution. It is only through this formula that we can verify if a distribution is normal. However, we can look at the graph of a normal distribution and get a good pictorial idea of the essential features of any normal distribution. All right. So good
So what
stuff.
this
Good
is
stuff.
saying, this is saying that in order to do it, you have to have the mean and the
Hmm.
median. I mean the mean and the standard
And the
deviation.
standard deviation, correct. Yeah. But don't worry, you'll be given it like when you actually see the actual homework questions, like it's mad simple.
Hold on.
Professor, I have a
Hmm.
question.
Go
Is
ahead.
this going to be on my TEAS exam?
No.
Is
There,
anything from this class going to be there?
yes, a lot, but not this particular topic.
Oh, okay.
So,
Okay.
it's mostly going to be, well, the basic math, two plus two, that kind of thing.
Mm-hmm.
Um, I feel like there's some geometry on it. Don't quote me on that. And
Okay.
um, and definitely they're gonna have like some algebra stuff on there. Maybe some like mean, median mode, that kind of stuff, but
That's
Okay.
not like heavy statistics.
I like the mean median mode and the coefficient and
Yeah,
what is it?
coefficient variation and all that. Yeah,
Yeah, I understand that after
yeah.
tutoring.
If you
I have
want,
a
if you
question.
want in office hours, we can actually look at that together and go over it if you want to know the
No,
topics.
because I know it already. I just have a
Yeah.
problem with the probability stuff we did in the test. That's the only
Got
thing
you.
I understand. But we could continue with the
No, 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 no. I mean with the T's exam. If you want to look at it, we could look over it during office hours if you want.
Oh, that's cool. I also
Yeah.
wanted to ask, are you gonna give us like a practice for the finals? Like, are we gonna get a finals practice, or are the quizzes practice for the finals?
All of
If
the
that makes
above.
any sense.
All of the above. We'll talk. We'll
Okay,
talk. We'll
so
talk more about it in December because we have a long time before then.
not really.
Yeah, yeah.
Okay.
We got a long time. Don't worry. All right. So look, the graph of a normal distribution is called a normal curve, right? And you see that word curve? That's just screaming calculus to me. You know, that's where I see curves in calculus. Anyway, it possesses a shape much like a cross section of a pile of dry sand, right? Because of its shape, blacksmiths would sometimes use a pile of dry sand in the construction of a mold for a bell. Thus, the normal curve is called a bell-shaped curve, right? We see that a general normal curve is smooth and symmetric about the vertical line extended upward from the mean. Notice that the highest point of the curve occurs over the mean mu, right? So just to recap, that's right here, right? Our mean mu, the highest point is right up here at the top, right? That's what they're talking about, right? Oops, I didn't mean to do that. If the distribution were graphed on a piece of sheet metal, cut out and placed on a knife edge, the balance point would be at the mean mu. We also see that the curve tends to level out and approach the horizontal axis like a glider making a landing. However, in mathematical theory, such a glider would never quite finish its landing because a normal curve never touches the horizontal axis. All right. So what they're talking about here is the endpoints, right? Let me make sure I got my pen out. I hate when this be happening.
The normal curve never touches
The endpoints, right? So one second, my thing just froze up on me.
that's the bottom, right?
Right. So more specifically, I'm
First
talking
the
about
bottom
here.
and
I'm
then the
talking
other.
about here, right? So I'm saying that even though it looks like this, the curve is getting really, really close to where the x-axis is, it's getting really, really, really close. It's never gonna actually touch it, right? It's gonna come really, really close though, but it's never gonna actually touch it, right? This
Oh,
is a
so
Go ahead.
oh,
Yeah. So this is actually an idea that is borrowed from calculus, right? This is something that they call like a limit. But again, not testing you on it, just talking to you about it. That's all. All right.
so it never touches the bottom,
Right.
the floor.
Right. It's like a skirt, I guess you could say. Like it's not gonna touch the ground, so to speak. Yeah. All right. So All right. The parameter sigma controls the spread of the curve, right? So remember, the standard deviation is how spread out your data is. So the standard deviation in terms of the curve is how spread out the data is over the curve, right? So the curve is quite close to the horizontal axis mu plus 3 sigma and mu minus 3 sigma, right? So that's 3 standard deviations to the right and 3 standard deviations to the left. Thus, if the standard deviation sigma is large, the curve will be more spread out. And if it is small, the curve will be more peaked, right? So the next figure is going to show a normal curve cupped downward for an interval on either side, sorry, of the mean mu. Then it begins to curve upward as we go to the lower part of the bell. The exact place where this transition between upward and downward cupping occurs are above the points mu plus sigma and mu minus sigma, right? That's one standard deviation to the left and one standard deviation to the right. In terminology of calculus, transition points such as these are called inflection points, right? All you need to know, this is where the curve begins changing its direction. Instead of going down, it's going up. Or instead of going up, it's going down, etc. Right? That's an inflection point.
So instead of going, can you show us in the graph, instead of going
Yeah,
down, it goes up, but then it comes back down.
exactly. So it has two inflection points, right? It has one right here. So it was going up, right? And then it stopped from going up and then now it begins to go down. That's the concave down. And then it switches back to going up. That's the concave up. All right. I think I made a mistake up here. There should be a minus and a plus here. This is concave down, this concave up. Sorry about that. Good stuff. Good stuff. So let's take a look at that peak picture, shall we? Oh, I didn't get it. So 1 second. I'll draw what they're describing. Just bear with me 1 second. Get this. All right, good to go. So let's say I have a graph like so, and let's say that it's like super peaked like this, right? Same kind of normal distribution, right? This graph is said to have a small, um, uh, or you could say a low standard deviation. But say you had a graph that was like this, where it's more spread out. Like it does have a peak, but it's more spread out. This has like a high standard deviation.
You touching the other one, it's not a bell curve.
These are both bell curves. They're
No,
not, they're not,
it's
they're not
touching.
even like this. I'm sorry.
It's touching. Hold on.
Oh yeah, I'm bad at art. That's why. I'm not a good artist, but imagine this is not supposed to be touching. This part is wrong, you know.
No.
But the idea is that you see how this bell curve, the mean is still in the middle, right? But it's like a super peak, right? And it's not as spread out. So this is a low standard deviation. But this one, where the mean is still in the middle, is more spread out, is closer to the x-axis, right? This has a high standard deviation. So that's what they're describing in the previous paragraph right here.
Parameter O controls the spread of the curve.
Good stuff.
So the O is their standard deviation, right?
Exactly. And if you forget, it's all on your formula sheet. I'll show you where in a second. Okay.
Professor,
So go ahead.
I'm so sorry. It's the last time I interrupt you, I promise.
You're
I just
fine.
wanted to remind you that I took you serious when you said that we have the permission to like simplify the formula sheet and
Yeah,
use
go ahead.
it for the test. So I'm actually printing out a more simple version.
Okay, sounds good.
Okay,
Okay.
thanks.
All right. So important properties of a normal curve, right? The curve is bell-shaped with the highest point over the mean mu. The curve is symmetric about a vertical line through mu, right? So that means what happens on the left is the same thing that happens on the right. The curve approaches the horizontal axis but never touches or crosses it, right? As you can see from me, that's very hard to draw, right? 4, the inflection or transition point between the coupling upward and downward occur above mu plus sigma and mu minus sigma. And number 5, the area under the entire curve is 1, right? Which we still remember that from our previous probability chapters, right? Because all of probability has to add up to 1. So the area under the curve is 1. Okay? The parameters that control the shape of the normal curve are the mean mu and the standard deviation sigma. When both the mean and standard deviation are specified, a specific normal curve is determined. In brief, mu locates the balance point and sigma determines the extent of the spread of the data. Okay? All good stuff. All good stuff. All good stuff.
Hold on, don't move.
I got you.
So the entire area under one is the area under the entire curve is one. What does that mean?
So let's like if we go back to the table, for example, right? You notice that all of the quote unquote answers on the table, they're all decimals, right?
Right.
0.005, 0.1000, point whatever, right? But none of them is ever one, right? Or like 3 or 4 or 5 or anything like that, right? So that's what's telling you that all of the area has to add up to one,
I'm
right? So
confused because I see one, or is it
yeah,
-1?
not -1, just one, right? Remember, all of probability, right? All of probability is between 0.
Wait, go back.
I'm sorry. All of
Sorry.
probability is between 0 and between 1.
All right, you could go ahead.
Right? It's all good. It's all good. That's all of probability, right? From the chapter 5 stuff all the way up to this. Always. And when you add all your probabilities together, they have to equal 1. Right? So that's why this statement remains true.
Okay.
Yeah. It could be a decimal, it could be a percentage, a fraction. I like fractions, right? So it could be different things. All right. Yeah. So the normal distribution curve is always above the horizontal axis. The area beneath the curve and above the axis is exactly 1. As such, the normal distribution curve is an example of a density curve, right? The formula used to generate the shape of the normal distribution curve is called the normal density function. If x is a normal random variable with mean mu and standard deviation sigma, the formula for the normal density function is here. All right, let's read it out. F of x is equal to e raised to the negative half power times x minus mu over sigma squared, all of that divided by the standard deviation sigma times the square root of 2 pi. Isn't that cool?
That's for a normal distribution.
Mm-hmm. Right. So the total area under any normal curve studied in this book will always be 1. The graph of the normal distribution is important because the portion of the area under the curve above a given interval represents the probability that a measurement will lie in that interval. All right. So in a previous section, we talked about Chevyshev's theorem, right? This theorem gives us information about the smallest portion of data that lies within 2 to 3, or let's say k standard deviations of the mean. This result applies to any distribution. However, for normal distributions, we can be much more precise, right? Results given by the empirical rule, right? We can get much more precise results given by the empirical rule. So that's what I'm going to talk about now, empirical rule. By the way, empirical rule, like this is your homework, in case y'all wonder. It's mad easy. Right? Y'all probably going to be disappointed
Chapter
when y'all
is
see the
this,
homework.
Professor?
Huh?
What chapter is this?
7. This is like real easy. Probably going to be disappointed when you see your homework, but we got to do it, that kind of thing. So here we go. Here's the empirical rule. All right. So for a distribution that is symmetric and bell-shaped, in particular for a normal distribution, approximately 68% of the data values will lie within one standard deviation of each side of the mean. Approximately 95% of the data values will lie within two standard deviations of either side of the mean. And approximately 99.7%, almost all of the data values, will lie within three standard deviations on each side of the mean. All right? So this is the empirical rule. Yeah, I should take a picture of it.
Hold on, don't leave.
All right.
Okay, so what does
Okay.
this mean?
All right.
This is for
So,
a normal distribution.
right. So for me, I don't know, the words don't really make much sense to me. Right. So what I like to do is I like to look at pictures. Right. So this picture makes more sense to me. Right. So this is the area under a normal curve. Right. Let me make that a little bit smaller. I feel like that's
Oh, that's
okay.
interesting.
All right. Let me make it a little bit smaller. Hold on. I feel like that's gonna look better. There we go. That's a good picture. Okay. So I have my mean mu, which is in the center right here, right? And if I go one standard deviation to the right and one standard deviation to the left, I'm telling you that this is going to contain 68% of my data, right? Going one standard deviation to the left, one standard deviation to the right. If I go two standard deviations over to the right and two standard deviations over to the left, that's 95% of my data, right? And if I go three standard deviations to the right and three standard deviations to the left, that's 99.7% of my data. That's all I'm telling you. It's simple, right? Any questions on this?
I'm sorry. Can you repeat that?
All right. If I go one standard deviation over to my right and one standard deviation over to my left, that's going to be 68% of my data is captured in that, right? For the empirical rule. If I go two standard deviations over to the right and two standard deviations over to the left, 95% of my data is captured within that interval, right? If I go three standard deviations over to the right and three standard deviations over to the left, 99.7% of my data is captured in that interval, right?
And Professor, how do you get
So
that again? In the middle?
it's given to you. It's going to be given to you. So
On
a
on a
question that might
table?
be asked, the table, oh, like this picture? No, it's just given like that. Like there's no way to derive it, you know? So a question
Oh.
that they might ask you, they might say, they're going to give you a story, of course, right? But when you read the story, it might say something like the mean is equal to like, I don't know, I'm trying to think of some like a basic number. Let's say like three. I'm just making it up. And the standard deviation is equal to like one. Again, I'm just making it up, right? So there's a couple of ways that they could ask a question, right? They can say, okay, um, how much of your data is, no, no, give me the interval in which 68% of your data is captured, right? So they want the interval for 68% of your data, right? How do I get that? Right? Well, we know 68% of my data is captured within one standard deviation to the left and one standard deviation to the right, right? So I know that my interval is going to be what? It's going to be mu minus sigma to mu plus sigma. Just plug in the numbers. So 3 minus 1 to 3 plus 1.
Oh, so I just put 34 plus 34 is 68.
Well, that's how much they're telling you that they want. That's how much of the data they want. But in between which two numbers is 68% of the data. So it's in between 2 and 4. I don't know if that makes sense, but that's all it is.
Not really,
Is
but
it always gonna be 2 and 4, or will those numbers
I made this
differ?
up. I made this up. Those numbers could be anything. It could
Gotcha.
be 34 and 96, whatever,
But it's
you
always
know?
gonna look like that, like how it's chopped up, like how it's cut up.
Yeah, yeah. The
Okay.
percentages don't change. Those are the same.
so where does the 3 and the 1 and the 3 plus 1 come from?
So the question was that they wanted an interval for 68% of their data, right? Now we know that 68% of our data is contained right in the blue part here, right? One
Mm-hmm.
standard deviation to the right and one standard deviation to the left. So I know that the interval for one standard deviation to the left and one standard deviation to the right is mu minus sigma to mu plus sigma. So all I have to do is just take what they gave me up here and then just plug it in. 3 minus 1, 3 plus 1. And that's it.
And it gives you 2 and 4.
Yeah. So in between the interval of 2 and 4, that's where 68% of my data is captured. Right. The only thing I made up was the mean and the standard deviation. Excuse me. Hold on 1 second. Sorry about that.
It's okay. So you
I
can
had a
use
little cough
any
there.
number.
Mm-hmm.
What is it? Everybody sick?
A little bit, I guess. Yeah. Yeah, so this could be any number, any mu, any sigma. The question is going to vary. They're going to have some kind of story attached to it, right? But long story short, they want to know an interval that contains the percentage of data that they're looking for. And that's it.
Okay.
And then they have like variations of the same type of question. Sometimes they can give you the reverse, right? Sometimes they could give you the interval like this. They could give you the interval and be like, all right, given that the mean is 3 and the standard deviation is 1, right? How much data is collected in this interval, right? So there's a lot of ways you could do this. You could draw it out.
Draw it out.
Yeah, your mean is in the middle 3. You go one standard deviation to the right is 4. Another one to the right is 5. Another one to the right is 6. One to the left is 2. One more to the left is 1. Another one, this would be 0, right? And then you have your
So, Professor,
distribution. Mm-hmm.
so going to the left is negative, and then
Exactly.
going to the right is negative.
Go to the
So
right is
this
positive.
is positive. So the
Yeah.
standard deviation, right?
Mm-hmm.
It'll be -2, 4
Negative,
if we
no,
drawing
positive
it out.
2. Positive 2, because it's 3 minus 1 is 2.
Oh, okay.
Yeah.
Oh,
So
so then this one is a positive curve because of the positive 2 and the positive 4, right?
yeah, I'm trying to think. I'm trying to think about this, how I say this, because technically speaking, those numbers could be negative. I just made a really easy example where it wasn't, but it could be negative, right?
And if it's negative, we just start like that, right?
Yeah. But
Negative.
but the question that they're asking you is, what is this area right here, right? And you know that this is one standard deviation to the right, and this is one standard deviation to the left. So one standard deviation to the right and to the left makes,
68%.
and then that's it. That's another way they could pose the same kind of question.
Mm.
So they would ask us like that, like with those 2 points or
Hmm.
whatever,
Exactly.
and we
Like
gotta.
they'll give you the mean and the standard deviation, but they can either give you the interval and be like, tell me the percentage, Or they could give you the percentage and be like, tell me the interval. You know? Excuse me.
Yeah, can you do it like that backwards? Can you do it backwards with the percent?
Wait, what would be
Hmm.
the interval then? Because the percent is those three, right?
The interval is 2 to 4 that was given.
Um,
And you have to figure out 68%. Um,
Right?
but then
But it could be anything, the interval, right?
it could be, but you can figure it out. You have enough information to figure it out.
Oh, can we do another one, but vice versa? We get the intervals and gotta find the percentage.
yeah, let's do that again, please.
I was gonna give you the percentage and you tell me the interval.
Yeah, we could do both.
All right, look, I'm looking for 95%. What's the interval?
That two, that -2, and that +2, standard deviation.
Give me the number.
Yeah, in the colors,
You can use
13.
the colors, or you can use the table, whatever you want.
The two 13%, 0.5%.
I'm looking for a number. Like I'm looking for a number.
Oh, -2 and +2.
No.
Mm.
Like remember how I had an interval before that said
2
from 2 to 4? I'm looking for an answer like that. So from
Oh,
what number to
okay.
what number?
From
Oh, so
1 to 2, 3,
let's see.
5.
All right, that's the answer.
1 to 5.
1 to 5. And that's
Oh,
it.
yeah, it makes sense. 1 to 5 because it's in that access point. But
Yeah.
Mhm.
that's only for the positive numbers, right?
But
The,
Professor, you throwing us
don't
off the dope.
these numbers could be negative. It doesn't mean anything, right? One standard deviation to the right, one standard deviation to the left is 68%.
But because 2 and 4 is in between, then the next one is 1 and 5.
That happens to be true.
And then
Yeah.
the 99.7 would be 0 and 6, right?
Hmm.
Yeah, that's a good way to go about it too.
Oh,
So you can always draw it out too. That's
yeah.
another option you have.
Once you said 1 and 5, it made sense because I was
Mhm.
thinking, okay, so maybe it starts at 0 and it goes in between this and that. But once you said 1 and 5, that makes sense.
It's because the
Yeah.
numbers he got right there, that U and the standard deviation 3 and stuff, we wasn't like, but when he do it like how he's doing it right now on the side, it made sense. That's what I pictured again. I just like, all right, that's why I was
Yeah.
counting like 1, 2, 3.
So,
Okay.
so
So
the
you could
99.7 will be 0 and 6, like she said, right?
right. So you could draw it out if you like. If that helps you answer the question, draw it out. That's fine. If you want to memorize this picture, memorize this picture. Your choice. Right? The only thing changing in the picture is the mean and the standard deviation. They're gonna give it to you in the question. Just plug it in and you're good to go.
See, I would like for you to take a question from the homework and see how they both correlate with each other. How can we,
I
because
would like that too.
once I hit the homework, everything is a blur.
I got you. So let me get to an example then. I got you. The homework is the same thing, it's just that there's a story. That's the only difference. Some story. But
Are
let
you
me
gonna give it to us in a story or like?
hmm
Oh,
Yeah, you're gonna see. You're gonna see. But hold on, let me just say one more thing before we go to an example, right? So the preceding statement is called the empirical rule because for symmetric bell-shaped distributions, the given percentages are observed in practice. Furthermore, for the normal distribution, the empirical rule is a direct consequence of the very nature of the distribution. Notice that the empirical rule is a stronger statement than Chebyshev's theorem in that it gives definite percentages, not just lower limits. For example, the empirical rule applies only to normal or symmetric bell-shaped distributions, whereas Chebyshev's theorem applies to all distributions. That's the difference. All
All
right.
right, let me write that down. So Sherry Chefs.
Mhm. So that's something you're more gonna need for like, when y'all go to like grad school and y'all in your PhD programs, y'all need to know that. All right, let's get to an example real quick.
Hold on, I have one question.
Go ahead.
So, Chef's rule, it implies to all distributions, right?
Right.
And the empirical rule is a normal distribution.
Exactly.
So Chef's rule could go either or.
Right. Like we only talked about two distributions in this class. We talked about binomial distribution and we talked about normal distribution. Just take my word for it. There exist other distributions that we're just not going to get into, right? But Chebyshev's theorem can be used to approximate all of them, right? But empirical rule only works with the normal distribution.
Okay.
So that's what that's saying.
So
All
the
right.
normal distribution is 68, 95, and 99.7.
Exactly. Exactly. In the empirical rule, right?
Okay.
So let's look at this. This is an example. Economics Internet Cafe has user connection speeds that are normally distributed with the mean of mu is equal to 28 Mbps. I forgot what that stands for. Megabytes per second, maybe. And a standard deviation sigma of 2.5, let's say megabytes per second, right? That sounds really slow. Anyway, what is the probability that a connection selected at random takes from 28 to 30.5 megabytes per second? So, do you understand what just happened here? Right? They gave me an interval. They gave me the mean and the standard deviation. I have to determine how much of the what you call it of the interval is being captured in that, no, how much data is being captured in that interval,
Wait,
right?
Yes. So
so
we gotta draw a line, right?
yeah, draw that little
we
bell
can we
shape.
can draw it out, right? That's an easy way to do it, right?
Okay.
Yeah, let's draw a line.
And the mean is in
So
the middle, right?
mean is always in the middle, right?
So
Okay.
that's
So this is mu equal to 28. Then we just go one standard deviation over to the right. Now,
29.
hold on, mu is 28, sigma is equal to 2.5. Right? So we're just gonna add 2.5 to it. So 28 plus 2.5, what's that? 30.05. Add
Hold on.
again.
I thought that was the way we was
28.25.
moving.
I'm sorry.
You said we gotta add them?
Right. So when we go to the right, we add the standard deviation. When we go to the left, we subtract the standard deviation. All right. So this is mu. This is mu plus sigma. The next one will be mu plus 2 sigma, which is what? 32 point hold
I
on. Why did I say oh 05?
don't know.
Right? So 30, 32, 33 actually. Right? And then the next one would be 35.5. And then going to the left, this would be 26, 25.5. And then this one would be what? Um 5 minus 2, that's 23. And the next one will be what? 21, 20, 50, something like that. And there you go.
Uh,
That's your normal distribution, like that.
how are you doing that? You subtracting it?
Right. So this one is mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. All right. I'm gonna try and draw this. I'm not the best drawer. I'm
Oh, when you go
trying.
to the left, you subtract, and on the right, you add.
Exactly.
You're going.
Exactly.
But there's
Oh,
a different way to add each time, right?
I'm adding this and I'm subtracting this. This is the standard
But what does that
deviation.
mean? U plus 2O.
So that's mu, which is 28, plus 2 times sigma, which is 2.5. And that's how I get that.
Yeah.
Oh, okay.
Mhm.
Understand.
And then it's the same thing for U plus
Okay.
3 times sigma, right?
Right.
And
Now
if you keep
let's
going, it's 4 on a 4, 5, 6.
no, that's it. We'll just
Oh,
stop right there. All right.
okay.
Let me grab this picture from before. Give me 1 second.
I have a question.
Go ahead.
So it says the probability, data connection, whatever have you. The probability is gonna be a percentage or no?
Right. It's that percentage that we had in the previous picture. The
Right.
68, the 95, whatever, that stuff. That's what I'm looking for.
Oh, it's gonna be like 34%.
Exactly.
Okay.
So just grabbing this picture again.
Oh, would I apply this theory with like this question I had put in the chat?
Hold on, let me check the chat. It's the exact same question. Yeah.
All right, all right. I just want to make sure.
Yeah. So going back to this question, they want to know between 28 and they want to know between 28 and 30.5, right? What's this area right here? So between mu and mu plus sigma. So we see
30.
that that's it. So that's the answer to the question.
34.
But okay, so all right, I understand that part. So
How we getting 34?
no, because the go ahead, show her.
The
Sorry.
picture, right?
It's already there. It's always gonna be there, right?
Yeah, same thing.
But okay, you see how so that's only if the question asks us for just that one direction. Because before you was doing the two, and then got 68 and stuff. So
Well, the two is just an example. Like it can ask you for one, it can ask you for two. But long story short, the answer for everything is in this chart.
So it's
oh,
either it's
Oh,
either gonna be
so
one or the
we
other,
could copy
right?
that chart down.
Right. Copy it, take a screenshot,
So we
whatever.
could copy that chart down and have it with us.
Yeah,
let me see if I can put it
But
on my
that's already in
phone.
the formula sheet, right?
it's not on the formula sheet. No.
It needs to be. I'm gonna put it on the back of it.
Okay.
Do we need it?
Not really.
Wait, in a
I
way, it
don't
kind of is, but it just don't have the numbers. It's like a table like that, though, all the way in the back, like
Mm-hmm.
mini version.
Yeah, we're
I
gonna
don't
talk about it.
understand the formula sheet, so I just feel like I have like a little like a better chance at understanding things when I just like rewrite my own formula sheet. Like
Okay.
you see how you just told everybody we could take a picture of that and
Yeah.
literally put that like on a formula sheet. That I think that's a great idea.
Okay. No problem with that.
Oh, Professor, by the
Mm-hmm.
way, I'm really sorry about your knee. Are you okay?
Yeah, I'm good. I'm good. Yeah.
I wanted to ask you,
Yeah.
I'm sick, and when I'm sick, I'm just so fucking miserable and crabby.
I got you. It's all
I
good.
hope you're okay, Professor. I
I'm
read that you hurt your knee.
I'm good. I'm good. I don't know how it happened, just over the weekend, and it just got worse. So I'm like, yo, let me just rest today, and then I should be good tomorrow.
Yeah.
You're not
Yeah.
supposed to like walk on an injury. And I think
Yeah.
when you hurt yourself, you like, okay, whatever, I'm gonna walk. I don't give a shit. You have to be careful.
I mean, like that's my initial mentality, to be honest. And
Yeah.
then and then life just be like, nah, slow down a little bit.
For
Yeah.
real.
Yeah.
Yeah, no, yeah, I've learned the hard way, so just be careful, you know.
Got
I've
you.
made injuries that were nothing something because I won't stop doing what I'm doing. So
Got
just be
you.
careful.
For sure, for sure. All right, so look, let's answer a couple questions, right? What does a normal distribution tell us, right? So, if a continuous random variable has a normal distribution, then the area under the entire distribution is 1. The area over a specific interval of values from A to B is the probability that a randomly selected value falls between A and B. The distribution is symmetric and mound-shaped and is centered over the mean mu. Most of the data, 99.7% of it, is in the range from mu minus 3 sigma to mu plus 3 sigma. All right. Questions on this? Anybody?
Mm.
This makes sense? Everybody's good?
Yeah.
Okay. Well, I could start on tomorrow's lesson. That's all I really had for today.
Can we do another one like this?
Yeah.
Sure. I mean, if you want, open your homework and pull out a question.
Okay, yeah.
Yeah.
Can we do the one that's in the chat?
Okay.
We have new homework, Professor?
Yeah.
Oh my God.
I haven't even finished the probability one.
Let me see how I copy this now.
Child, I'm behind too.
Wait, that ain't even gonna copy right. Hold on 1 second.
Let
Yo,
me let me sign into my homework.
bear with me 1 second, you guys. Just bear with me 1 second. Where's my really?
And which
Crap,
problem
I
is that
need to
from?
exit out the
Which
damn
section?
internet.
Which homework is this? 6 point what? 6.3?
It's not
7.4.
7.
Oh, 7.1.
Oh gosh, this is 7. Hold on.
Yeah.
You know, Professor be trying to give us all heart attacks.
Yeah.
All right, so we got one that says supposed to.
But we
Should I?
already finished all the hard questions for the class, though. The rest of the class is easy, so we good now.
I'm signing in now so I could take a look at it with y'all.
Got you. This
Yeah.
this what I saw in the chat. So the heights of Frenchmen are normally distributed with the mean of 69.4 inches. So mu is equal to 69.4.
Is that part of the
And
whole?
I think this is someone's homework question. And a
Which
standard
section?
Everybody's
deviation.
homework question is different, right?
Oh, right.
I
Everyone's
thought
question
Yeah.
is different.
I thought it
No,
was the
not all of
same.
them. Not all of them.
Yeah.
Not all of them. What section is that
No,
from?
damn.
7.1.
7.1.
Mm.
Look at the
Which
one I sent you, Professor, on the group chat. You see, it's different.
the
That's the
height?
first one. That's my first
Professor be like,
question.
y'all not cheating today.
No,
Let me
right. Like why
see.
you did that?
So the standard deviation is
That one's even easier.
I'm dead.
Yeah.
Because I got Russian men. Fuck.
Yeah.
Why you did this?
The same thing. All
so
right, so
Professor, you will
mhm,
use that chart for this?
exactly, you
Okay.
Okay.
know.
Hold on,
So
wait. The chart.
this one right here.
Yeah, that top one.
Okay.
Let me see what I could do.
So the easy way to do it, just draw it out. Like
Right?
you already know what the
God damn
mean
it,
and the
I'm trying
standard
to go
deviation
into the
is,
homework.
you know?
Right. Hold on, wait.
So
Um,
the mean is 234 and the what is it called? The
Standard
mu
Stevie,
deviation.
standard deviation is 59. Oh, that's different. Oh wait, I'm doing the
32.5.
69.4.
homework. I'm sorry, it's the homework.
Yeah. So
Oh, here's the homework one.
69.4 and then 3.5, right?
That's the deviation.
Oh, we gotta start. Oh, okay, never mind.
And then you just go one standard deviation over to the right. So you're just adding 3.5.
65.
So what is that? That's
And
72.9.
so
Then you're going to add another one. So that's going to be 75, 76.4. Add another one. That's going to be 79.9.
72.9, yeah. Point 4.
Yeah. Then you want to go one standard deviation over to the left, right? So you subtracted 3.5. So that's going to be
65.
66, 65 point, what?
9. I think.
65.9. That sounds about right, I think.
62.4.
Yeah.
And the next one, 62.4.
All right, 62.4. And one more. That's gonna be, what's that? 59, 58.9, something like that.
Let me see.
I don't know. Somebody check that for me.
58.9, yeah.
All right. So let's just say that this is the highest point. I'm just making this up. Just bear with me. I'm not really good at drawing. I'm trying over here. Something like that. Right? That's your mean. And this is like one standard deviation to the right. All right. Two standard deviations to the right and the left, and then there we go. All right, let's go back up to the question. So question A says, how much of the data falls between 65.9 and 72.9? Right? So I want this area right here.
68.
Exactly. So 68%, that's A, right? How much of the data falls under 58.9%? So where's 58.9 right here? So how much data is over here?
0.15%.
Exactly. Now,
But
how much data is over 67.05? 67.05.
67.05. That's
I
in
don't, I don't even know where that is. Hold on a
it's
second.
30,
between
65 and 69.
Say it again.
It's between 65 and
It's
69.
between 65 and 69.
Let me see something.
Yeah.
I'm just checking something. Hold on.
I think it's
69.4.
34%.
Huh.
Professor,
How about that?
how do you make people love math? Like what can I do to love math? I fucking hate this.
Just think of money. That's all.
Jesus.
This is not even real math. This is just like looking at a picture and picking out the numbers.
That's the sad part. The sad part is
Mhm.
that this is like really simple math and I still don't get it.
It's okay. With practice, you'll get it.
I hope.
Mhm. So this one's a little bit harder, this question. So this
Yeah, because
question
that's
is like
yeah.
somewhere like in between this. So for sure, we know
Yeah.
we know it's more than 50%.
I
For
got my
sure. Right? Because this line right here, right, is all of this, that's 50% for sure. That's half of the graph, right? But we need
Yeah.
to figure out how much is this part right here.
So you gotta do oh
And
yeah.
we know it's not 34%, right? But it could be something like maybe 16% or so, right? So how could
Mm.
we figure this out?
professor. When it says and, that means add, right?
And means multiply.
Oh,
Yeah, that's another section. So what I could do, I could take the 67.055, right? Subtract the mean from it. Wait, no. Hold on. Yeah, subtract that from the mean. Let me say it like that. So 69.4. Let's figure that out.
Okay.
So 69.4 minus
Minus
67.055.
2.35 345.
All right.
2.345.
So 2.345. So I'm trying to figure out now how much of that is the standard deviation. Like, is that half a standard deviation? Is that a third of a standard deviation? Is that
that's
two-thirds of a standard
35%.
deviation?
Times
35?
it by I don't know.
Ain't it 95%? That's the answer.
95%? No, no, no. The answer to this is going to be something between 50. No, what's
Maybe
34
like
again? 34 is
60.
going to be, it's between 84% and 50%, the answer. All
I'm
right.
so lost. My bad. I was doing the homework.
Or
Yeah.
is it
Yeah, me
76?
too.
Is it 76%?
That's possible. That's possible.
Because this is my very first question on the homework.
Yeah, part C is a little challenging. I know it's more than 50%, and I know it's less than 84%, but to figure out which one it is, you know? It's not exactly half because half of 3.5 is like that's 1.75. So it's more than half. Let me see if I take 3.5 and I divide it by 3.
Why you have to
No.
make such a difficult one?
I know this a hard question. I know, I know.
Why? Why you did that?
Right. Why?
It just came out like that.
No, that's my very first homework
I feel like
question.
you
Yeah.
That's
should do your
question
own
one in my
homework.
homework.
Mm.
That's
For
crazy.
me, that's
I
problem
feel like
two.
professor is
Mm.
using like reverse psychology. He
Yeah.
probably thinks that if he just kills us with math, we might just end up majoring in math.
Y'all should major in math. It's so fun.
You see what I
You
mean?
know?
Mm.
Professor, I
Yeah.
fucking hate math.
Why? It's amazing.
I'm not
Listen,
good
if
at
you
it.
were
I
to
don't
sit
like
here,
anything
Yeah.
I'm not good at.
if you were to sit here with me and we could talk about this for like 4 semesters, I will major in math. Because by that I will learn. I will know what the fuck I'm doing. But this
Well, it
1
is,
week
but I'm sorry,
topic
Professor.
is
It is
Hmm.
76%.
The 76%? All right.
Yeah.
All right.
I think it's
That
The only time I
that
do
was a
math is when
challenging
I'm
one. I'm
food
not gonna lie.
shopping. That's
Shoot,
it.
how you got that? Let me know so I could do because mine is kind of like that. I need to know.
I mean, so how I did it, just thinking off the top of my head, right? I saw that what's it called? 2.345, right? How I got that number was I took the mean, right, which is 69.4, subtracted it from the question I was given, 67.055, and then I got 2.345. Then I noticed that if I took the standard deviation, which is 3.5, and I multiply that by 2 over 3, I get something close to the 2.345. I get 2.33333, right? So that means that it's 2/3 of a standard deviation, right? So that being said, right? Um, 2/3 of the standard deviation, that should translate to I'm trying to think how to change it in terms of to percentage the percentages.
See, I don't
Um,
like that, Professor, because when we do the homework by ourselves, how are we supposed to understand that when you can't even figure it out for a second?
I am figuring it out. I'm figuring it out in
But
front
look
of
how
you.
long it's taking you to figure that out.
But that's the fun part about it.
No, for you.
Yeah. That's why you go to tutoring too, and you could do it with the tutors as
Professor, can
well.
I say something,
Professor, they got
including
it wrong in tutoring. Don't even start because they got it wrong in
exactly?
They
You literally
Exactly.
do?
took it out my mouth. Professor,
Yeah.
can I say something without you getting upset?
Yeah, go ahead.
I'd rather you tutor
Because
us.
we love you, we just don't like the
Oh, for
work,
sure.
right, guys? Look,
Yeah, we don't.
I'm gonna give you a perfect example, right?
I
Psychology
agree.
class.
Hmm.
Psychology class is not my major. I mean, psychology is not my major. I'm not gonna be a psychologist. She
Oh
told us, look,
man,
guys,
they get
I'm not here.
they make good money
Yeah,
too.
she said to us, look, guys, I'm not here to make anyone's life difficult. Your major is not psychology. Okay, so what I'm gonna do is I'm gonna make the final online so that you can get it right and move on to your actual classes that you need.
What a
You feel
nice.
me? Because psychology is not your major. So yeah, we had a lot of work. I'm not gonna lie. I had to read 1,000 books and do 1,000 assignments and 1,000 discussion boards and 1,000 essays and shit.
Nah,
But
that that
she's like,
sounds that
I'm gonna
sounds
do your
scary.
finals online. Why? Because this is not your major. This is not what you're gonna do at work.
That sounds scary. I'm not even gonna lie.
Scary,
Yeah, that sounds like mad work.
scary
Yeah.
to do the finals online, open book,
To
so
be
we can
honest
pass.
with you, like the one thing y'all don't have to worry about is the final. Like the final's mad easy.
What?
You know
Oh,
how
I
you
thought
know
you meant
you
we
know how
don't
you
have to
know it's
worry because
easy?
there
Because I'm
isn't
not
one.
making it. That's how you know
Oh,
it's easy.
You say that about all the tests.
so that means there isn't one?
No, there is a final, but I'm not making it, so that's how you know it's easy.
Um,
So you're giving us hard tests on purpose.
who
But you
making
think
it? Right.
The department makes it.
Oh gosh.
But when I tell you that
So
they
the
take
test
mercy, oh
is.
my gosh.
I hope
So,
so.
Just pray for
Professor,
each
I
other,
have a
guys.
question.
Uh-huh.
So the exams is what, like 5% of the grade?
Nah, that's like 30%.
You said 3%?
Like 30.
Oh man.
Yeah. Your homework is worth more though. That's the most.
This is gonna be really difficult
So
to
we could
pass this
pass this.
shit.
So we could pass this class solely based off homework.
No, you got to get like at least a
You said it's
50
more.
on every exam and a 50 on the final. You could pass.
Mhm.
That's
Professor,
not
I
bad
thought it
though.
was your favorite class.
You guys are. This is
No, you
easy,
hate
right?
us.
Nah, it's simple, I promise. I promise. This is real simple.
I mean, there's nothing wrong with a little multiple choice.
Okay.
Right,
Say it again.
right.
I feel
Say it
you.
again.
Like process
Say
of
louder for the ones
elimination
in the
is
back.
key.
Yo, I be
I'm
I've
waiting for
looked at other people's multiple choice tests and statistics, yo, that should make me cry, yo. It'd be mad hard. Like you
Professor,
be looking at it
seriously?
for
that's
real.
way
You be looking at it like, yo, like how you get this answer? Like the way
Professor, you do process of elimination and critical thinking. Multiple
yo,
choice is
literally
the
yo,
easiest.
wait till you see the T's. The whole T's exam is multiple choice.
because with
I do
that,
really
at
good.
least you know if you're going in the right direction. Because if you get something that's not on that thing, then you know you did something wrong and you can go back and redo what
Mhm.
you know what I'm saying?
Yo,
Yeah.
I seen people with multiple choice questions that be like, all right, they didn't know what to do, but they knew how to do the question in two ways. And when they do the question in both ways, both answers is there.
Damn.
So they're
Well,
like,
too bad,
yo,
Professor. We not people. We not
Right.
people.
Because
We
It's
usually
people that would like the multiple
always
choice.
it
C.
happens to me is
And you know you gotta know it's C.
I'll
Professor,
be
we
reading
all find
something.
the class hard, so I know we're not all bugging.
but y'all all got great grades though for finding the class hard.
I don't feel comfortable with this other test I'm about to take. I'm trying, Professor, but the shit don't make sense, man. I'm trying. I'm trying.
Well, for test
I
three,
even
nah,
rewrote
test
the
three gonna be
formula.
No,
nah,
test
test
No,
three
I
gonna
two.
mean
be real
test
easy.
two.
Test
I
two.
haven't taken test two. I haven't
Me
gone to
neither.
school.
I mean three,
Yo,
because I didn't take
Me
two
neither.
either.
you could ask them. Test two is mad easy.
No.
Yeah, right.
Yeah,
Don't lie to me, guys.
I don't think so.
yeah.
are you crazy, Professor? Test
No.
was not easy. I didn't even do half of that. I didn't
Oh
even
my
do
Yo,
god.
5% of it.
all I did was look at the first page, and most people got 100 on that. I'm like, all right, so I know the rest of the test is cake. Like,
I bet you test two is
mhm.
more diabolical than test one.
Nah,
What's
Test
what
one
grade
needs
was
an
on it? Do
exorcist.
y'all remember?
nah. Test one was light though. It's just mean median mode.
Yeah,
Yeah,
that
that
was
one was easy
easy.
after I did the tutoring for it. But the
Not the
Yeah.
second one was
It
super
was
easy.
the
more than
quadrant
that.
stuff. Mara, you know the quadrant stuff was really difficult.
What quadrant? What is that?
What what do you call it? He put something on the test that we didn't do in class. That shit was difficult.
Which one was
In
that?
test one. It
I
starts with a
did.
Q. Yeah. With
I,
that weird squiggly long division looking line.
the standard deviation.
No, it wasn't standard deviation. Standard deviation is not that bad.
The square root?
It looks like a square root, but mixed with a whole bunch of other bullshit.
I
I'm
think
We
I know
sorry.
what you're talking about.
we did
Because
that.
once I did the tutoring for the last two questions and tutoring, I understand it. I understood the standard deviation.
That's good.
You know, the fact that we went to tutoring and still got it wrong just speaks on how hard it was.
Yeah,
For
that's
real.
true. Yeah,
Like I had to go
I'll
back
give you that.
3 different times
Same.
Yeah,
because they was wrong.
that's true. I'll give you that.
Even the tutors, I like some of my tutors. They was like, "Oh wait, these tricky ass questions." Like they had to double back. Like they was like, "It's
Yeah,
wrong."
they was getting mad at me because I kept trying to use my formula sheet, and he was like, "You can't use that. Put that away."
That's right.
I know.
Same.
I would
But
have just
yo,
walked off.
I'm telling y'all from
Yo, the
day
lady
one
didn't
though.
even let me use the calculator.
I'm telling you from day
Oh,
one
God.
though, like the formula, the answers are on the formula sheet. You
Professor,
know.
I rewrote the whole entire formula sheet. I'm hoping I could have
No,
time to
you're
print it
gonna
out
you're gonna take.
tomorrow.
I mean, I don't think it's
That's
gonna
like going
help,
to
but
Spanish
okay.
class and saying, "No, this is easy." You heard?
I don't know.
All right, so
Oh,
what's the answer
I
to
don't
C?
know.
To see 76%
Right.
they got
76.
percent.
And how did you get that?
So how I was thinking about doing it was I took the standard deviation 3.5 and I multiplied it by 2/3. So what I was thinking to do was I'm trying to think if this is right. If I want to do 2/3 of 34% or 2/3 of 50%. Let me see.
I just shaded it in, and I just got rid of the decimal and the 4, and it seemed like the right thing. So,
Okay. So this is like what, 26%? So how do I get 26%? That's the question. So let's see if I took 34 times 2/3.
Wait, why did I get the first one wrong?
I don't know. I have to see your question.
It says the height of an American. Hold on.
No, babe, we got different questions. This is a French man.
I know, but
Yeah. Yeah, we got different questions.
I got
And
an
I got a
American
Russian
one.
man.
I got an American one.
And then the height. Wait, let me see. Where's mine? I got a
Where's
Russian
mine?
man.
I got
Where's
a,
mine? Hold on.
I'm gonna put it in the chat, the screenshot. I'm fucking weak.
Okay.
And it's different measurements
I
too.
got an
That's the most
American man. I got
beautiful.
an American man. Damn.
Who got the Russian man?
Y'all saw and that's disappointed with the American man.
I mean, it could be. Hey, it could be anybody because everybody comes to this country.
That's true.
He probably got easier heights though and stuff.
I tell you, no, you the might though. I'm sorry. Oh man.
this weather is giving homemade hot chocolate.
Yo,
Yes.
facts.
Weather's giving emergency room.
Oh, honey, I hope
That
you feel
too.
better. You sound terrible.
Oh, I'm done.
Is
I've been
anyone allergic? Is
crying.
anyone allergic to nuts in the class? I was gonna bring some stuff for Thanksgiving.
No.
I'm not.
No.
No. No. Okay.
I don't
Let
think
me
so.
let me ask y'all,
Just in
did
I
case.
don't
anybody
think
go to the
so.
event today or no?
No,
No,
Professor.
I was.
So
In
hold
Professor,
on.
oh,
Coaston.
we're
Professor,
too cold
it's
for
a
that.
federal holiday. I am
In,
home.
that's the
Yeah,
one in
That's true.
Coaston, right? In
I was
Yeah,
Coastal.
just about to
yeah.
come to
No,
class.
it was too windy, Professor Od. It was about to
It's in
fly me. I was about to
Coastal.
fly away home.
I didn't even know about the event. Like somebody just like told me. I was like, really?
I saw the
Guys,
email.
repeat
Look
after
at,
me.
look at my
Today
look
is
at
a
the chat.
federal holiday. Repeat after me, everyone. There's a federal holiday today. Stay the fuck home.
Yep, today is holiday pay. Time and a
Okay.
half.
Professor, you seen the chat? I put that.
Yeah,
Well,
yeah.
I know the last one's wrong, but
I see two questions in there.
You know what's crazy? My old boss used to give us the day off because she didn't want to pay us time and a half.
Oh wow.
That's crazy.
Yeah, she would tell you just like that. She'd be like, "You could come in, but you're not getting time and a half."
What was she?
Uh-uh.
Yeah,
What was
but they should give you time on the books because if you don't work, you get time on the books. But if you work, you get paid.
Yeah, I was working on the books is like, legally you paying taxes and stuff, right? Like you claim taxes every
No,
year.
like as if you work the day of the holiday, you get paid. But if it's your day off of the holiday, instead of you getting paid,
Oh,
you get 8 hours of time, annual
Right.
time, sick time, or whatever time you would like. That's
okay.
how it's supposed to be.
Thank you. Thank you, thank you, thank you.
Man, I need you to give a master class to us, educate us on that.
Word.
Mm.
Nigga said no, but they be very quick to call you when you late and when you don't want to
Yep.
share something. They
What
be full of
about when you get
CPS.
fired? I mean, I never got fired, but like I used to feel bad when I would see people get fired with like a 5 minute notice versus when you leaving a job, you got to give a 2 week notice. That's fucked up.
This is why
No,
they
you
say
just
everything
go
you
like
gotta email.
unemployment. You go right
Email
to
everything.
unemployment
Yeah.
because you work for that money. So if they let you go, that's
Yeah.
what that insurance is for that come out your check every quarter.
Yep.
So that's why a lot of jobs they're not really fire they take a while to fire you because they don't really know the labor laws and they'll have to pay you your salary every week for up to 12 months. So they try to get you to
Yep.
quit.
Mm.
Oh,
Yep.
right.
Or
If you quit, you don't get that, and if you get fired, you do get that.
Exactly.
Yeah, you're right about that.
Exactly.
or in other cases you could be job abandonment and that's when they think they slick and they don't write to you. They let you basically F yourself until they
Yep.
job abandonment. You abandon
Yeah,
your
that
Interesting.
job.
that's the reason why I didn't get no unemployment because I was the one that quit. I didn't
Yeah,
get fired.
abandonment.
I got
Professor,
it.
Girl,
you
you
can
never
Interesting.
don't never quit no job.
huh?
You
Let
had a
them
fall right
fire
I
there.
you.
I don't feel
know.
good. I
Interesting.
fall.
I didn't even know all that.
I would have fell. I'm
Yeah,
sorry, Professor.
we gonna have to have a master class before class
He
ends.
said, break a leg.
All right, let's look at this real quick. So this was posted, I want to say
Right.
Natalie. So suppose the scores of students
Yeah.
on the exam are normally distributed with the mean of 388, all right, and a standard deviation of 63.
Oh.
According to the empirical rule, what percentage of the students scored between 325 and 451? Right? So 325 to 451. Go ahead. Somebody was gonna say something.
Yeah, don't kill me, Professor. I just want to let you guys know because they're gonna be sold out by next week. If you currently have a shopping cart on Shein or on Amazon or on Temu worth $500 or a little less for Christmas decor, go to Dollar Tree instead because they have the same shit for $1 each.
Dollar Tree is bomb.
Mm. Thank
So
you.
bomb.
It's
Mhm.
65%,
Thank you.
68.
Oh, look.
68%. Yeah.
Is it? I didn't even get a chance to do it yet. All right, I trust y'all.
Yeah, it is.
So this is 325.
I
This
wish
is
those were the
451.
questions. That's it. Like that's all you gave us. That was it. This one. That's it. You
That's
could give us
it.
5 of these. No, no, this same one, not the A, B, C. This. Just one. What is the
But
percent?
even the ABC is the same thing.
No, because you doing more. You gotta
Why is my
figure.
question being difficult?
Let me
I
see
have the
your
same
question.
question but different numbers.
Under 57.9%. Why?
Hold on, my thing
Which
just
one is that?
froze on
Question two?
me. Give me 1 second.
These kids. Oh my God, I gotta charge my phone.
1 second. Okay, we good. Let me just get this. Kill this also. All right, so the heights of American men are normally distributed with the mean of 66.3 inches and a standard deviation of 4.2 inches. According to the empirical, what percentage of men are? Okay, under 57.9%. Okay, let's see.
99.7.
Okay. So easiest way is to draw it out. say 66.3. And then what's that? 70.5. And then 74.7.
And 78.9.
78.9. And
And
78.9.
then this
62.1.
62.1.
57.9.
7.9. Okay.
And 53.7.
53.7. And then blah, blah, blah.
Boom.
Right.
Mm-hmm.
So
Also, it's 99.
this would be like one standard deviation. This is 68%. This would be two. This would be the 95%, whatever.
Mm-hmm.
And then this is the three. That's the 99 point.
7%.
Yeah. All right, let's look at the question, right? So under 57.9. Oh, hold up. I need to copy that picture for this.
All right. Oh, look at y'all.
Yeah. Okay. So remember that this is mu plus sigma, mu minus, oh, excuse me, plus 2 sigma, mu plus 3 sigma, mu minus sigma, mu minus 2 sigma, mu minus 3 sigma, right? So you want to know under, you want to know under 2 sigma. 1 second. I don't know why this thing is doing this, but you're just gonna add these two together.
Which one?
2.35 with 0.15. And that's the answer to it.
So the in between,
Mm-hmm.
2.5.
Mm-hmm. No, not in between. No, this one.
yeah, we gotta add those two together.
Yeah, and that's it.
So we gotta add 2.35 plus 0.15.
Exactly. Because that would
Because
be
the question,
under.
but that's because the question is asking what again?
Under. Oh, hold on, let me scroll up.
2.50.
Yeah,
Yeah.
under 57.9. Oh.
Mm-hmm. Now the next one says 63.48 something
Are you kidding
and
me? How was I
69.
supposed to know that?
Guess?
Wait, so you said the first one was under 57.9. So what I'm
Mm-hmm.
supposed to do with that line is subtract the 0 point, I mean, what the hell?
Not subtract, add. Add the 0.15% and the 2.35%.
Oh, okay. When it's out of the range, right?
Kind of, because they're looking for all of the people that are shorter than that number.
Oh,
So that's why
okay.
you're just adding those percentages together.
Okay.
What, 95? That's a tricky question.
It is.
Yeah.
I don't like that.
The next one is really tricky though.
Yeah.
Let me see.
So the next one is 63 point something through 69 point something.
63.
So it's not 68, but it's something in between 68.
Like 69,
No, not more than 68. It's less than 68.
60.
It could be that. Try it.
Yeah, I don't like that. What do you mean,
Maybe
sorry?
So
67.
this is where I get confused. You need to, what am I trying to plug in to figure out what is what?
So we want to know how many standard deviations are between
Yeah, I get
these
that
numbers,
part.
right?
Right.
So basically take the mean and subtract the 63 point whatever from it. And then on the flip side, take the
Which one is this?
69.
This is for C. This is for C.
Yeah, for C. For
So
C.
we take the mean. The mean is 66.3,
Uh-huh.
right? And we subtract whatever is between 60. Hold on, because I know what you're trying to say. Hold on. So
So
it's 60.
basically what's happening is that it's not going to be 68%, but it's going to be
Oh.
something smaller than 68. Close to 68, but not 68. So it could be like, let's say something between 60 and 68.
So we take the mean, and what do we do with the mean?
So I would take the mean, which is 66.3,
Right.
and I would subtract out the lower end from here. 63.486. And I get 2.814. All right. So I want to know 2.814 is what percentage of the standard deviation, for example.
2.814.
Yeah. And then I want to do the same thing on the other side, right? So the 69.114.
And how we do that? 2.814% of 66.3 is what?
That's the question. What is it?
Right. So we just gotta subtract.
4.
Hold on one second. Minus 66.3. Right. Oh, it's the same thing. 2.814. How about that? All right.
So how you got that? Show us how you got that. You just
So
subtracted?
this one was the 69.114 minus the 66.3. And then this one was the 66.3 minus the 63.486.
0.3.
Right?
Oh yeah, 0.6.
Yeah.
Right.
Correct. It says it's incorrect.
What's incorrect?
2.184.
This is crazy.
0.18. No. That's the standard deviation. Like that's how much of the
Oh,
standard deviation was covered in it. So now we have to translate that to the percentage, that's what they're looking for.
So we have to add
Right?
it.
So I want to figure out like how much, like what number can I multiply the standard deviation by to get that. That's what I'm trying to figure out. So like 28 2.814
right.
is equal to 4.2 times x. So divide by 4.2.
How
Let's
do we
see
get
what
the
that is.
4.2?
That's the standard
Oh, that's the
deviation that
standard
was given to
deviation.
you. Yeah.
Yes, you're right. Oh, so that's it. We just gotta take that number and do that.
Yeah.
Oh, that's it. So once you get that,
So it's 63.489.
Could be. I didn't get to do it yet. So I got 0.67, right? So
Wrong.
hey,
I'm thinking if I take 68 and multiply that by 0.67, that don't sound right.
You see, why you give us questions like this? I don't like that. You need
This
to
a
make up
this a
your
good this a good question.
no,
In the
because
in the in the
you give us
next
questions. How
section
are we
that we're gonna
supposed to
learn,
figure that out after one lesson?
just think about it. But listen, in the next lesson, we're actually gonna learn a technique on how to figure out questions like this. It makes it way simpler.
Okay.
I'm just trying not to use that technique in front of you right now because we're gonna learn about it next time.
So don't give us homework that we can't finish off without
Y'all can
breaking.
finish it. Y'all can finish it.
Yeah, with ChatGPT.
So the answer for this